Oh my gosh, I'm so thirsty. Uh-oh, I'm out of water. See, the amazing thing about camping is you can bring your habitat to some wild places. This tent provided a great shelter for me last night. In order to make this wild place my habitat, I need a couple more essentials. I need to find food, and I need to find some water. Wow, this is the first time I'm seeing where I camped in the daylight. I'm in such a wild place. Come on, let's go. I'm not sure if I'm a very good predator. These wild animals are pretty fast. Fortunately, there are some native plants that are growing naturally in this wild place. Maybe I'll be able to pick some of these. Ooh, and I found a natural source for water. This natural spring water is gonna be so tasty. All right, regardless, welcome to your second video of OWLS. So last week, during our first video of OWLS, we talked about everything outdoors. We talked about what an ecosystem is, living things and non-living things working together to form a community. We talked about what an organism is, all living things. So I'm an organism, you're an organism. This tree behind me is an organism. Grass is an organism, but water is not an organism. The sky is not an organism. The sun is not an organism. The tiny microscopic living things that might live in the sky, those are organisms. Then we honed into the shrub steppe ecosystem and we talked about all the different structures that make a shrub steppe unique. We talked about different types of grasses, we talked about shrubs, we talked about the living crust and the lithosol, and we can't forget the riparian area. We also talked about photosynthesis and the food chain. So green plants do photosynthesis. What green plants need for photosynthesis is sunlight, water, and carbon dioxide. They use those things to create sugar for themselves to use and grow, and then they also give off oxygen. The food chain, we talked about producers, consumers, and decomposers. Producers are things that do photosynthesis. So producers are all green plants. And then we talked about consumers and how consumers eat producers. Consumers also may eat other consumers. And then decomposers are the organisms that turn dead stuff back into soil. So, moving on to this week's video, we're gonna get wild. We're gonna talk about the wilderness. We're gonna talk about different relationships that you see in the wilderness. We're gonna talk about how organisms adapt to survive in their habitat. And we're gonna talk about what a habitat is. So sit back, relax, and let's get to it. All you need for this video is a sense of adventure.
Hi there, Huckleberry here, and welcome to your second video of OWLS. Last week we learned all about the shrub steppe ecosystem and the different structures that make a shrub steppe a shrub steppe. Today we're going to be talking about relationships, habitats, and adaptations. As you can see, today I am not in the shrub steppe. I am actually in a forest ecosystem, but a lot of the same principles apply across different ecosystems. This will be a good opportunity for you all to take what I am learning and the examples I'm giving you from the forest and applying them to the ecosystem around you. So in every ecosystem, everything is not working alone. There are all different sorts of relationships that happen in ecosystems that explain why everything is connected in different ways. So we're going to explore 3 of these different relationships today. The first one is a helping relationship, or a mutually beneficial relationship. And this means where both organisms, both either animals or plants, are benefiting or getting something good out of the relationship. So one example of this is a squirrel and an oak tree. Take a minute to think about that. How could a squirrel and an oak tree help each other out? Well, the squirrel is getting some acorns from the oak tree, so they're getting some food. But the oak tree is actually being helped by the squirrel because the squirrel is helping to spread the seeds further away. Another relationship is between flowers and butterflies or bees. And these pollinators help flowers out by spreading their pollen to different flowers so that they can reproduce. And the bees and butterflies are getting some food out of it. A final example of a helping relationship is between bears and berries. So bears obviously are getting some food out of the situation. They're getting some berries that they can eat. But the berry plant is also benefiting because as the bear eats the berries, berries have seeds inside them. So those seeds are being passed through the bear. Bear wanders around a little bit and he spreads the seeds as the seeds pass through him. So now take a minute to think of your own example of a helping relationship in nature. Another type of relationship in nature is competition, and that's where two organisms are competing over the same resources. Now these resources could be all sorts of different things. They could be competing over food, they could be competing over a mate, over territory, over space, over light, and both plants and animals do this. So one example would be two squirrels that are competing over the same acorns, right? They both need that food to survive, so they're both trying to get the food source from each other. Another example, two trees in a forest that are trying to grow taller than the other so that they can receive the most sunlight, which trees need for energy in order to do photosynthesis and survive. Trees could also compete for water through their root systems, and they could be competing for space in that way. So trees need lots of space around them underground so that they can reach their roots really deep and really far to tap into that groundwater, which is a source of water that they need, again, to do photosynthesis. One other example of competing could be two rams that are butting heads, and they could be competing over a female. Now take a minute to think of your own example of a competing relationship in nature. The final type of relationship that we'll discuss today is a predator and prey relationship. You've probably heard of this one before. So a predator-prey relationship is when one animal is trying to hunt and eat the other one. And the predator is the one that's doing the hunting, prey is the one that's being hunted. A good way that I use to remember which is which is through this little hint. So predator has its eyes on the front, and that means that they are ready to hunt. So they have really sharp vision with their eyes in front of them. They're ready to hunt down some prey. Prey have their eyes on the side, and that tells us that they are ready to hide. They're able to look all around them. They're always on the defense. So eyes in the front, ready to hunt. Eyes on the side, ready to hide. A good example of a predator-prey relationship would be a coyote and a squirrel. One question I get a lot is whether a cow eating grass or another animal eating a plant is an example of a predator-prey relationship. And though it might seem that way, it's actually not. So in order for it to be predator-prey, the prey needs to be an animal, and it needs to be able to run away. So the cow isn't trying to sneak up on and attack that grass, right? The grass is just a plant. So that's a little bit of a caveat between different relationships and clarification on predator-prey. So now we're going to move on and talk about how different organisms can survive in their habitats. So plants and animals use something called adaptations in order to survive in their habitat. So first, let's define that word habitat. A habitat means a place that has food, water, and shelter for an organism. So any good habitat has to have those three things. So for humans, our habitat might be a house, right? In our house we have food, we have water, and we have shelter. But humans are pretty easily adaptable. Humans live in pretty much every corner of the world. And so we've gotten really good at finding habitats in all different sorts of places. But animals might have some more specific types of habitats, and so could plants. So certain organisms have a very specific set of conditions that they need in order to survive. Like I know that there are certain plants that can only live in one particular little area. So habitats are really important. And adaptation is something that a plant or animal uses to survive in their habitat. They could have either a physical or a behavioral adaptation. So a physical adaptation is something that that plant or animal has, like a feature that you can see. that helps them to survive. A behavioral adaptation is something that they do. It's like an action that they have that also helps them survive. Let's think of some examples of physical adaptations. So for animals, a physical adaptation could be something like the sharp teeth on a coyote or on a mountain lion, and those help them to be predators and to be meat eaters. Another adaptation could be the thick fur on an animal that helps to keep it warm. Another adaptation could be, in humans, we have what are called opposable thumbs, or we have the ability to use our thumbs. And this is a pretty cool adaptation that lets us do all sorts of different things that other animals can't. Plants also have physical adaptations, and plants have some pretty crazy adaptations. And we're gonna look at a few examples in a minute, but these could be anything from flowers that help to attract pollinators, big leaves that help to absorb sunlight, or really deep, strong roots that help trees to get water. Behavioral adaptations, like I said, are things that animals do in order to survive. One example of that is migration. You might have heard of this before as something that birds do, but whales also do it, and butterflies also do it. And what it means is to move somewhere during a specific time of the year in order to survive. Birds usually fly south towards the equator where it's warmer in order to hang out there for the winter, and then they'll come back north in the summer. Another example of a behavioral adaptation is wolves who hunt in packs. So certain animals have behaviors that help them hunt better, and that's something that wolves do, is that they work together in order to trap their prey and have food in order to survive. Now take a minute to think of your own examples of some physical and behavioral adaptations that animals or plants have in order to survive in their habitat. And specifically try to think of examples for organisms that live in the shrub steppe ecosystem. Now let's go take a look at some examples. So here we are in my mom's vegetable garden, and I think that we can find some really cool plant adaptations here. Let's go look. We've got some lettuce, we've got some squash, we've got some carrots. Ooh, over here we've got some peas. And if you look closely, you can see that these peas are trying really hard to climb high. They're doing that so that they can get enough sunlight for photosynthesis. But they have these really cool little tendrils, they're called, which are kind of like little arms, and they're wrapping themselves around this trellis so that they can have the stability that they need in order to stand tall and absorb sunlight and compete against the other pea plants. So over here we have some cilantro that's growing, and there's two different cilantro plants, and it looks like they're both trying to grow nice and tall so that they can reach the sunlight. And something else that I noticed is that the leaves on the top are really skinny, and the ones on the bottom are really flat, and they take up a lot of surface area. And the more surface area you have, the more sunlight you're able to absorb. So the ones on the bottom, they maybe don't get quite as much sunlight coming down, but because they have so much surface area, they're still able to absorb a lot of that sunlight that comes down. This pea plant also has these beautiful flowers that it uses to help attract pollinators, so like birds and butterflies and bees, so that it can spread the pollen and help this flower and this plant to reproduce. So right here I found a blackberry bush. And as you can see, we have some really sharp thorns right here. Ouch. And those serve as a really good defensive mechanism against predators that try to eat them. That's all for me today, and I'll see you guys again next time. Have a great week.
Beep, 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 beep. Hey, what's happening? Steelhead back here. Ready to get a little bit wild this week. Today I've come to one of my favorite habitats, the riparian area, and I'm going to be doing some exploring here, seeing what kind of organisms we can find, what their habitat might look like, where their food and water and shelter is, explore some adaptations. Speaking of adaptations, this bird, I don't know if you can hear this bird. Ever since I got here, this bird has gotten really active. It's kind of flying circles around me. And I have a feeling it's an adaptation to protect other birds. I'm thinking there's a nest nearby with some young birds. This bird is trying to distract me to get me away from the nest. This bird really doesn't want me here. Good adaptation to defend itself. And we're really lucky along the Columbia River to have so many tributaries, have so many rivers flowing into the Columbia River. And so I'm on one of those today. And I'm gonna do some exploring, see what organisms we find, look at their habitat, maybe do some fishing, see if I can be a predator to some fish. One of the activities you're gonna do today is searching for relationships. So going out and looking and seeing if you can find relationships, looking for squirrels having a relationship with oak trees, or see if you can find any birds that have relationships with any trees or shrubs. Looking for pollinators, looking for bees and butterflies and their relationship with flowers, looking for predator-prey relationships. So maybe looking for a bird. See some predators up above. Hunting something, or maybe a dragonfly looking for some food. Dragonflies are predators. They're actually the best predator in the world. So going out and looking for these relationships, looking for competing relationships. See if you can find two plants competing. One of the plants that is all along the river here are these willows. I imagine there's some competing going on with all of these willows, trying to find, imagine these willows are trying to find some space. They're trying to get their roots down to get the water, trying to grow the tallest, biggest leaves so they can get some sunlight. And there's other plants growing here too, some flowers. And so I imagine these are all competing. Or maybe you see two animals competing. Maybe there's two squirrels or a couple of birds both going after the same food. So going out and looking for relationships. All right, another activity is looking for habitats. So I have found this pile of wood here, and I'm thinking that this would be a good habitat for maybe some snakes, invertebrates, some things that don't have backbones, like some ants, or maybe a scorpion could live in here. So we're going out looking for habitats. Okay, the other part to this activity is you're going to build a pretend habitat. So I have picked up a couple of sticks off the ground and a leaf, and I found a nice spot here next to the water where I'm gonna build a little pretend habitat for something. That bird is not happy that I'm here. Ooh, there's a cool bird coming this way. That's a predator. That bird is a predator. Okay, here's my little habitat. So I have the shelter with just some sticks leaned up here. My food is actually this garden. I'm growing this garden back here, and I'm gonna be able to eat some of the food, and some of these plants are gonna grow over the roof to give me a little more shelter. The water is just right here. So I'll be able to just walk down to retrieve water when I need it. I'm also gonna get water from this moss over here. I'm gonna let that absorb some water and get water that way. I have a nice little bed under there. But before I go fishing, I wanna figure out what kinds of organisms live in this river. So I'm gonna turn over a couple rocks and look underneath, see if I can find any organisms. Ooh, there's a little worm. Okay, so maybe if I use something that looks like a worm, see what else we can find. And that worm's habitat was underneath this rock in kind of a sandy bottom area. All right, I'm in a little bit of a shaded area now. See if we can find any other organisms living in here. And what I'm looking for, they're called aquatic macroinvertebrates. I just found a very tiny one. You might be able to see it moving on the rock. I think that's called a water boatman. It has like it has little fins sort of on the side that are like wings, but they're also like fins that rotate. All right, so the organisms I'm looking for, they're called aquatic macroinvertebrates. So aquatic, we're talking about water. Macro means small, but we don't need any special tools to see it. We can see it with just our plain eye. And then invertebrate is an animal that does not have a backbone. So I'm looking for things in the water that are small and they don't have a backbone. So like the worm. Woohoo! I just had one land on an adult macroinvertebrate. That's called a mayfly. Today, this is an adult mayfly, and today is the only day that it will live as an adult. So its number one goal is to reproduce so that its species can continue. I can tell it's a mayfly because it has 2 tails and those very distinct wings that are sticking up. So in the larva stage, they have gills on the side that they're breathing through. There's that mayfly. Pretty cool. So I could use something like that for bait. And because the mayflies are here, it also tells me this water is pretty clean. I wouldn't want to drink the water, but because mayflies are living here, mayflies are sensitive to pollution. They can't live with pollution, so that tells me that this water is pretty clean coming off the mountains. All right, we got one in there. It has quite a bit of sand on it, so it's tough to see, but if you can see the little fluttering on the side, those are the gills. So they bring water in through those, and then they shoot it out of their bottom, and that's how they breathe. And I see 3 tails, and they're kind of in the shape of a fan, and 6 legs. So this is an aquatic macroinvertebrate, also an insect. And this is the larva stage of the adult one we were just looking at. So notice it went back to that water to be able to breathe. And I'm wondering if we're not finding as many right now. About a month ago, I was pretty close to this same area looking for these macroinvertebrates, and I was finding a lot more, and they were a little bit bigger. And I'm wondering if they had more habitat at that time, more food and water and shelter available to them, because the river levels were higher about a month ago. There was more water flowing down the rivers, and so now they don't have as much habitat, and so there aren't as many, and they have morphed into their adult stage and grew the wings into flying around, help pollinating, reproducing, and making more food. Okay, so part of all of this is their life cycle, and then the water cycle as well. So all of this water, I'm releasing this invertebrate back where I found it. Now it doesn't want to leave my hand. There we go. All this water's flowing into the Columbia, heading out to the Pacific Ocean, where it will stay for a while and then evaporate into the clouds, precipitate back down onto the mountains, and it just keeps going around and around. The water cycle, the life cycle, seasons, all these cycles just keep the world turning and keep the ecosystems running. Actually, the world's revolution and rotation cause some of those cycles, cause those seasons and day and night. Then your last activity is looking for adaptations on organisms. So you're just exploring, looking around, looking for organisms that have wings, or maybe a plant that has thorns, whatever it is. Flowers, that's an adaptation. So you're looking for adaptations, thinking about how those adaptations might be used. You're building the habitat, looking for habitats, and looking for relationships.